Okay, so today we're going to do a second part of limits of functions using properties of limits. So let's get started. For each function's f, find the limit as x approaches c of the average rate of change from c to x. That is, find the limit as x approaches c of the average rate of change. So this is a very important concept in calculus, the average rate of change and how to find the limit as x approaches c. And this is the formula that we're going to use. So let me read it again to you. The limit as x approaches c of this, that represents the average rate of change. So here we go. What I want to do is I want to start by writing what is f of c. F of c, all we have to do is replace the x with c. So 8c cubed. Now, since we want to find the limit as x approaches c, in this situation c is 2. So we'll plug in a 2. We're going to evaluate it. First you do exponents. So it's 8 times 2 cubed, that's 8. And if I multiply these two numbers, I get 64. So f of 2 equals 64. Now, let's evaluate the limit. I'm going to start off by saying limit as x approaches 2, because my c is 2. So I'm replacing it there. And then notice in the average rate of change, we have f of x, which is our function. And our function is 8x cubed minus f of c. But remember, c is 2. That's why I wanted to calculate it outside over here. So f of c is going to be my 64. So I'm going to plug it in here, 64, divided by, and now if I keep looking at the average rate of change, it says x minus c. Again, x minus c. And x minus, instead of c, because c is equal to 2, we're going to write 2. That's how we set it up. So now the next thing to do is to evaluate. Now remember from the previous video, all we have to do is use direct substitution. So meaning I'm going to get this 2, and I'm going to replace it there. And I'm going to get this 2, and I'm going to replace that x. If you plug it in, you end up with 0 over 0. So that tells me that it's an indeterminate form, and I have to somehow simplify so we can cancel something out. So let's see. Limit as x approaches 2. In the numerator, they have an 8 in common. So I'm going to factor that 8. And that leaves me with x cubed minus 8. Let me fix that. Okay. All we did was factor an 8, that's it. But now I have to factor this because I want to cancel the denominator. So I need to factor this. This is a difference of cubes. Now from Algebra 2, or even last semester, you have to remember this, that if you have a cubed minus b cubed, and we need to factor the difference of cubes, that factors like this: a minus b times a squared plus ab plus b squared. So that's going to be the way we're going to factor it. So now, if I go here, 8 is the same thing as 2 cubed. So remember that. So 2 cubed, so it's x cubed minus 2 cubed. And according to this formula, this is going to be our x, and this is going to be our 2. Again, Our a is x and our b is 2. Notice it's b cubed, so 2 cubed gives me 8. And then we're going to replace the a with x, the a with x, the b with 2, and the b with 2. So according to this will factor as this. So I have to write limit as x approaches 2. We have an 8, and then it was a minus b, which is x minus 2, parentheses, and then it was a squared. Remember, this one is a, this one is b. It was a squared, so it's going to be x squared plus a times b. A times b. In this situation, it is 2 times x plus b squared. B squared. B is 2, so 2 squared is 4. All of it over x minus 2. You don't need parentheses, but I put them there just so you can see what I'm going to do right now. So now the x minus 2 cancels the x minus 2. That's what we wanted to do. So now I'm left with this. Limit as x approaches 2 of 8 times x squared plus 2x plus 4. Let me double check. X squared plus 2x plus 4. Yes. Now here comes the easy part. Plug in. We're going to get this 2. You're going to plug it in wherever you see an x. Okay? So now we have 8. And that's going to be 2 squared plus 2 times 2 plus 4. Notice that the limit sign is no longer there. You don't need it anymore once you plug in. So if we use a calculator or not, you don't have to. Let's see. This gives me 4. That gives me 4. So I have 4 plus 4 plus 4. That is 12. 8 times 12. And then if I multiply 8 times 12, that gives me 96. And that is our answer. Okay, let's do another example. This time we have f of x as being the square root of 2x. And our c is 5. So like we did earlier, I'm going to write, what is f of c? F of c is square root times, square root of 2c. Now, we know what c is, it's 5. So we want, what is f of 5? That's going to be square root 2 times 5. And that's just the square root of 10. Okay, so now let's set it up. So we have limit as x approaches c, but this time c is 5, and according to the average rate of change, it's f of x. So f of x is square root of 2x minus f of c, where c is 5. So I already did the work on the side, so that just gives me square root of 10 divided by x minus c. X minus c, but c is 5. So there we go. That's how you set it up first. Now, if we plug in the 5, if we plug in this 5 there and there, again, we're going to end up with 0 over 0. That tells me that I have to manipulate, simplify, do something. So since I see radicals, I'm going to multiply the numerator and denominator by the conjugate of the numerator. So the numerator is this, 2x square root of 10, and then denominator is just x minus 5. I'm going to multiply by the conjugate. The conjugate is just 2x plus the square root of 10. Same thing on the bottom. Okay, now that I have it set up, we're going to multiply. Now, the denominator, I don't want you to multiply it, just leave it alone. But when we multiply conjugates, all you have to do is multiply this times this minus this times this. So if I rewrite it, it's going to be this. Limit as x approaches 5. Square root of 2x times square root of 2x is just 2x. And then minus square root of 10 times square root of 10 is 10 over all of this, x minus 5. And then write out the other factor. Now notice that I did not distribute. I don't want you distributing. Still, I notice that I cannot cancel these two out, but they do have a 2 in common. So I'm going to factor that 2 before I cancel anything. So it'll be limit as x approaches 5, factor of 2. That leaves me with x minus 5. Now I will be able to cancel it. Okay, so now I am able to cancel the x minus 5 over x minus 5. That leaves me with limit as x approaches 5. Now, in the numerator, we're going to end up with just a 2. And in the denominator, we end up with square root 2x plus the square root of 10. So now what we do is plug in the 5 wherever you see an x. Wherever you see an x, you plug it in. So let's plug it in. And when we plug it in, remember, you don't need the limit sign anymore. So it'll be 2 over square root 2 times 5 plus square root of 10. Well, this right here, that's just a square root of 10. And if I have a square root of 10 plus another square root of 10, that gives me 2 square root of 10s. So 2 over 2 square root of 10. And I notice that I can cancel out the 2's. Now remember, we're left with 1 in the numerator. Denominator, we have square root of 10. And if you want to rationalize the denominator, because sometimes we do, sometimes we don't, your final answer should be square root of 10 over 10. Okay, so another very, very important concept in calculus is how to find the limit of the difference quotient. Now, this right here that I just circled, that is the difference quotient. So what we want to do is find the limit as h approaches 0 of the difference quotient. Okay, so here we have a function f of x, 3x plus 5. What I want you to notice on the difference quotient is that we have f of x plus h, and we have minus f of x. So again, f of x plus h. So to make things easy, I want you to, here on the side, write what is f of x plus h. Well, all that means is that you're going to get this x, you're going to replace it with x plus h, meaning this x gets replaced with x plus h also. So now it's going to look like this: 3, but instead of x, we're going to write x plus h. Make sure you put it in parentheses, and then plus 5. So again, notice the x was replaced with x plus h, and you replace it everywhere. So now we know what f of x plus h is. And you could either leave it like that here, or you can expand it. Actually, let's make things easier. So why don't we go ahead and distribute the 3. So we have 3x plus 3h plus 5. So that is our f of x plus h. So keep that in mind. So again, let's find the limit of the difference quotient. So the definition, or the limit of difference quotient, is this: limit as h approaches 0 of f of x plus h minus f of x, all of that divided by h. Now let's substitute. So limit as h approaches 0. Now let's look at it. Here, let me highlight. Here we have to put f of x plus h. This is f of x plus h right here. So we're going to replace it with that. So it's going to be 3x plus 3h plus 5. Then it says minus f of x. This is f of x right here. So now we'll replace that. It'll be minus. Now, since it's minus, I want you to put parentheses around it. Minus 3x plus 5. All of that divided by h. Next step. Distribute the negative. So it's limit as h approaches 0, 3x plus 3h plus 5. Distribute the negative, minus 3x minus 5. All of that divided by h. Now we haven't done the limit yet. We need to simplify it as much as we can before we take the limit. So again, limit as h approaches 0. Notice that the 3x minus 3x, they cancel out. Positive 5, negative 5, they cancel out. So I'm left with 3h divided by h. And before we actually evaluate the limit, I can simplify it even more. We can cancel the h's. So we're left with limit as h approaches 0 of 3. And if you remember correctly, the limit of a constant, because 3 is a constant, there's no h. I can't plug in that 0 anymore. The limit of a constant is the constant itself. So the limit as h approaches 0 of 3, it is equal to 3. On to example number 4. So we're going to do the same thing. We want to find limit as h approaches 0 of f of x plus h minus f of x, all of that divided by h. So just like we previously did on the side, let's find out what is f of x plus h. So f of x plus h tells me that everywhere I see an x, that is going to get replaced with x plus h. So it'll look like this. 2. So the x is being squared, and now x is being replaced with x plus h. So we have to use parentheses, x plus h squared, plus, I'm just going to put these in parentheses. You don't have to, but let's just get used to that. The x becomes x plus h. Notice again. X plus h, x plus h, x plus h. Compare it to this. Okay? So now, let's simplify things. Here, let me move this around. Let's use the lasso, right? Isa, you like the lasso. Alright. Let's simplify. So what I want to do is expand x plus h squared. I'm going to do the shortcut. I'm not going to explain that one because you should already know it. I've done it too many times. So it'll be 2. If I expand x plus h squared, the binomial, it'll be x squared plus 2xh plus h squared plus, now I'm just going to drop the x plus h. X plus h. Okay. Let's simplify even more. So distribute the 2. So we have 2x squared plus 4xh plus 2h squared plus x plus h. All of this is your f of x plus h. Okay? So now we're going to replace the f of x plus h and f of x. So here we go. Let me move this back. Okay, here we go. So limit sh approaches 0. Now notice it's your f of x plus h. This is your f of x plus h. Again, your f of x plus h. This is your f of x plus h. So let's replace it. So it'll be 2x squared plus 4xh plus 2h squared plus x plus h. Now we're supposed to do minus f of x minus f of x. Now when I see the minus in front of the f of x, it just tells me do the opposite. Do the opposite. So minus f of x. If f of x is 2x squared plus x, then minus f of x is going to be the opposite of that. And the opposite of that is going to be minus 2x squared minus x. It's the opposite. And if you don't remember that, just go ahead and put parentheses around it over h. All right. It looks nasty, but it's not. It'll be good. So now we're going to start canceling. So let's see. Ivy, tell me, what can you cancel there? Yes, you're right. What else? The x's? The x's? Okay. Is there anything else that we can cancel? Nope. Okay. So now let's rewrite it. Limit sh approaches 0. We're left with 4xh plus 2h squared plus h. All of that over h. If we try plugging it in, notice that it's h approaching 0. H. So that means that wherever you see an h, that's supposed to have a 0. But we get 0 over 0. So that means I have to simplify even more. So I can factor an h, limit as h approaches 0. If I factor an h, we're left with 4x plus 2h plus 1 over h. So now I can cancel the h's, and we are left with this. We're left with let's see, limit sh approaches 0, 4x plus 2h plus 1. So now we're ready to evaluate the limit, but I don't want you making this mistake. I saw this the other day where you plug in the 0 into h, not x, because h is approaching 0, so you plug it into that one, not to x. It's h approaching 0, so it's, you plug it into h. So if I plug it into h, you don't need the limit sign anymore, so it'll be 4x plus 2 times 0 plus 1. And if I simplify that, that just leaves me with 4x plus 1. Okay, let's try one more. They're not difficult, it's just tedious. Here we go. Let's see. We're gonna do it again. Now, oh, hold on. Diana, Mariana, can you please stop with your TikToks? Okay, thank you. All right, let's get started. So here we go. Again, I need to find out what is f of x plus h. So we are going to replace the x with x plus h. So it'll be 3 over x plus h squared. For this one, I won't expand now. No, we should. Let's go ahead and expand now. So if we expand it, it'll be 3 divided by x squared plus 2xh plus h squared. Okay, so now let's find that limit. So it'll be limit sh approaches 0 of f of x plus h minus f of x, all of that divided by h. So now we're going to replace them. We're going to replace f of x plus h. So limit sh approaches 0. That'll be 3 over x squared plus 2xh plus h squared minus f of x, and f of x is just 3 over x squared, all of that divided by h. So now what I want to do is simplify this complex fraction, this mess right here. So we need the common denominator. Let's see, so limit sh approaches 0. So now, common denominator, I'm going to write it as one fraction. And the common denominator, just like I taught you, it's going to be this denominator times this denominator. That'll be the common denominator. This denominator times this denominator. But don't distribute, just leave it in parentheses. So it'll be, I'm going to put x squared first, parentheses, x squared plus 2xh plus h squared. And now to get the numerator, what I want to do is multiply 3 with x squared, 3 with x squared. That gives me 3x squared. The next step is to multiply 3 with this denominator. So it's like this. Notice there's a negative in front. This negative makes the 3 negative. So that means that when you multiply with this, you have to distribute the negative. So my numerator is going to be minus 3x squared minus 6xh minus 3h squared. Again, the reason is because there's a negative in front, that belongs to the 3. And finally, in the bottom, we just have h. So now we're going to start simplifying. Notice that I can cancel 3x squared minus 3x squared, and that's it. And if you imagine that the h is over 1, remember that if you have two fractions, a over b divided by c over d, then I want you to write multiply it like this: a times d, so the outside ones, and that goes on top, and then the inside ones, b, c, that goes in the bottom, in the denominator. So let's see, that'll be limit sh approaches 0, and we are going to end up with, let's see, can't get this line, stay here. Oh my god, oh, that's better. Okay, so in the numerator we're going to end up with a negative 6xh minus 3h squared, and in the denominator we're going to get h x squared times x squared plus 2xh plus h squared. Now we can try to evaluate, but if you try to plug in the 0 wherever you see an h, we're going to end up with 0 over 0 again. So that tells me that I have to factor something. And then I notice that in the numerator I have an h and an h squared, so we're going to factor the h. So it'll be limit sh approaches 0. We're going to factor an h. So it'll be h minus 6x minus 3h divided by all this again. Now we can cancel the h's. Once we cancel the h's, we are left with limit as h approaches 0. In the numerator, we are going to end up with negative 6x minus 3h. And in the denominator, we're going to end up with x squared plus 2xh plus h squared. Now we can evaluate. Finally, let's evaluate. And when I mean evaluate, means plug in the 0 wherever you see an h, because it's h approaching 0. So it'll be negative 6x minus 3 times 0 over x squared plus 2x times 0 plus 0 squared. So once you do that, we can start simplifying. So we will end up with negative 6x in the numerator. In the denominator, we'll end up with, since this is 0, this is 0, it's really just x squared times x squared, which is x to the 4th. And if we do just one final step where I have to simplify, I can cancel one of the x's, and we're left with negative 6 over x cubed. And that is our answer. Okay, this one will be our last example, and all it's telling us to do is find the limit, find each limit. So anytime you have a limit problem, you always try to use direct substitution first, always. So if I plug in a 0 into h, notice it's h approaching 0, which is the same type of problem that we just did. If I plug in a 0 for h, I will end up with 0 over 0, an indeterminate form. So that tells me that I have to manipulate it, I have to simplify somehow. Whenever I have radicals, if I have a problem involving radicals, then automatically I think I need to multiply by the conjugate. So the conjugate is going to be the conjugate of this numerator, which means get this negative sign and just change it to a plus sign. So I have this over h. Now we're going to multiply numerator and denominator by the conjugate, so it'll be x plus h plus the square root of x, again in the denominator, square root of x plus h plus the square root of x. Now the reason why I like multiplying by the conjugate is because all you have to do is multiply the first term with the first term, that's it, and the radicals cancel out, and then minus the second term with the second term, and then that's it. That's how you multiply conjugates. So we have limit as h approaches 0. If I multiply the conjugates, we're going to end up with x plus h minus x, all of that divided by h over, again, the conjugate. Now we will start simplifying. I notice that in the numerator I can cancel the x's, so we're left with limit as h approaches 0 of in the numerator we're left with h, denominator still the same. Before we do anything else, I notice that I can cancel out the h's, make things easy. So now I'm left with limit as h approaches 0. In the numerator, don't forget, we're left with a 1. In the denominator, we're left with x plus h radical plus radical x. Now we can evaluate the limit. This is where the calculus comes in. So what we're going to do is replace the h with 0, the h. And then we do not write the limit sign anymore. So it'll be 1 over square root x plus 0 plus square root of x. Well, the square root of x plus 0 is just square root of x. So if I have square root of x plus square root of x, that gives me 1 over 2 square root of x. And there you go.